I wanted to give you a quick video on how to let your computer do some of the work for you, for problem 9 especially. You can't just write a solution and then run the test and think that the test is going to pass. You need to build up your solution by solving some of the sub-problems involved. If you want to know, for let's say I'm player 0, which words did I type the fastest, I need to know for each word how fast I typed it. I need to know the fastest time that it was typed, and I need to compare those to figure out whether I typed it the fastest. Those steps are incremental, and you can solve parts of the problem in order to make progress toward the goal. Now, some people do this by just focusing on reading their code and trying to figure out what it would do. But sometimes it's more productive to look at what your code does do. So if I run the test case for question 9, I unlocked it already. It's going to tell me that it imported word time and fastest words from my file, set up this test case that hopefully you've gone through and unlocked, and then called my function on that test case, and it expected this output, but that's not what it got. It got nothing. Here, you have an opportunity to display information about what you've done so far. You want to know what word times is? Print it out. What's word times? I save that, run it again, and here's what I printed out. Okay, so a word times is a list of lists of lists, where each list is a pair, that's the start, and the time that it started. So 0, 0.2, 0.4, 0.8 are part of word times. But they're not what I want. What I want is the difference between the elapsed time when I'm done with luck and the elapsed time when I'm done with great. That difference tells me how long it took to type the word luck. So let's see if we can print that difference. It helps to preface each of your prints by a word so you can tell which one is which. Word times I printed out here. And the difference between luck and great, well, I have to figure out how to get this value. So that's word times elemented index 0, elemented index 3, elemented index 0, elemented index 3. That gives me this value, luck 0.8. How do I get out the number 0.8? Well, I could treat it like a list and get elemented index 1. That's supposed to give me 0.8. Let's check and make sure it works before we move on. Nope, it doesn't work. Invalid syntax, because I put a colon here instead of a comma. So I do it again. I got 0.8. That's not the difference I was looking for, but it was the number I was looking for. The difference I'm looking for is this minus what? Well, same player, different word, same element within that word time value. If I run that again, I'm supposed to get the difference between 0.8 and 0.4 is 0.4. Oh, so it works. And what if I want the other player's difference between 0.8 and 1.19? Well, I could try it for the other player. This is the difference for P0, and this is the difference for P1. I'll just change the player. And I should get another number. The difference between 1.19 and 0.8 is 0.38999. Really? It is really 0.39, but Python and all other programming languages have a hard time representing differences between decimal numbers exactly, and so there's a little bit of rounding error. Okay, so we've got as far as being able to see what our code does on this example, which I think is important. But what we haven't done is figured out how to generalize this for different players and different words. And that's where it's a good idea to write a function. So that's what I put on Piazza as a tip. If I want in general to know how long it took for any given player, P, to type any given word at index W, then it's going to be a difference like this. Except for, instead of saying that it's always player 1, we'll say it's player P. And if instead of saying it's always word 3, we'll say it's word W. and word W minus 1. So we'll run that and see what happens. Well, we got a syntax error. Why is that? Because I have a stray parenthesis. Okay, that was not my point, but let's fix it and run it again. Now what happened is, well, nothing new happened because we didn't print out anything new. It should be the case that we should be able to print out difference P as just the time it takes for player 1 to type word 3, and we should get this same number again. Let's check and see if it worked. Look, it did. Okay, so now I've kind of tested some little function that I wrote. Now, why do I care about doing it for any combination of a player and a word? That means I can get the times per word for player 1 by using a list comprehension. I can call time on every different W for player 1, every different W for every W in a list of the different words. And how many words are there? There's n words, different words. Let's run that and see what happens. Well, the times per word came out as negative 1.19. That seems totally wrong. 0.6. Actually, 0.6 isn't wrong. That is the time that it took to type what. And 0.2 is not totally wrong. That's the time it took to type great. So this one's okay, and this one's okay, and this is garbage, and somehow we lost the time it takes to type luck. What happened? Well, we can try to debug it. What happened here is that we had an incorrect definition of time. If this is supposed to be the time it took player P to type word W, then this should have been, I think, W, and this should have been a W plus 1 to account for this pseudo word start at the very beginning. Then I could run it again and see what happens. List out of range. What's wrong there? Well, maybe we should print W and P and see what the results are. So we're calling time PW on P and W, and let's see what happened. Oh, it wasn't in this list comprehension that there was a problem. It was this call that I had left in there as a test that's a problem. This is really word 2 that I'm interested in. That's the word luck. So if I run this again, then I can see that my goal was to compute 0.6, 0.2, 0.39, and that's exactly what I have now, 0.6, 0.2, 0.39. Now when you achieve something, you should clean up a little bit. I don't think we need this anymore. I don't think we need that anymore. I don't think we need either of these anymore. And I get a pretty good sense of what word times is. So now I can get the times for player 1, and let's get times for player 0 while we're at it, and just make sure all of that looks good, and then we'll have made some progress. Okay, let's check. P0 took 0.2, and then another 0.2, and then another 0.4. 0.2, 0.2, 0.4. That's good. Player 1 took 0.6, and then another 0.2, and then another 0.39, 0.6, 0.2, 0.39. Now my function seems to work, and I'm using it correctly in this list comprehension to compute the times that I need. If instead I wanted all times for luck, what would they be? Well, I get the time for each player of the word luck, which is the element at index 0, 1, 2, for P in range n players. So let's run that and see what we get. All times for the word luck were 0.4, which is 0.8 minus 0.4, and 0.39, which is 1.19 minus 0.8. Well, that looks pretty good. So if I wanted, for example, the fastest time for luck, then I could just take the minimum of that list. So I feel like we're getting somewhere now. The fastest time for luck was 0.39. So was this the fastest? No, because it's bigger. Is this the fastest? Yes, because it's the same. And so I know that luck is something that should be in the output for player 1, but not player 0, assuming a really small margin. So please try to make progress on number 9 by writing expressions and running them on examples instead of just trying to think of how to get to the final solution because you'll make more progress that way. Good luck.